This is Math 139, Preview Section P, and we're going to look a little bit more closely at the geometry associated with slope. We've already said that the slope actually tells us about the steepness of the graph of the line. But I'd also like now to split that into two concepts. The steepness is not only how rapidly or how the graph moves, but it's also in what direction. Does it go up or does it go down? When we read a graph, we always read it from left to right. So we're thinking a positive slope, the graph is going up or rising from left to right. In other words, it looks like this. With a negative slope, the graph falls from left to right. And so we'd be looking at something like this. So first thing the slope gives us is direction. Once we know direction, we can stop thinking about whether the slope is positive or negative and just think about its absolute value without the positive or negative designation. And that tells us about the steepness. If the absolute value of the slope is large, we have a very steep line. Now this can be either a very steep rising line or a very steep falling line, but it's just steep. If the absolute value of our slope is small, then we have a line that goes up gradually, or it's not very steep. Remembering back to what we were talking about in the last section, we also know if the slope is 0, we have what kind of line? A 0 slope. It doesn't go up or down at all. That's a horizontal line. And if our slope is undefined, it's actually an infinitely steep line. We can't put a numerical value on it. And those were the vertical lines. All right, let's take a look and just kind of practice using those concepts with the lines that are graphed down here near the bottom of the page. We've got 6 lines, and for each one, I want to first of all decide, is the slope positive, negative, 0, or undefined? And then we'll also talk about rising and falling. And we'll also use just a little bit of new language here. I want to talk about increasing, decreasing, and constant. When the graph is rising, we say the function is increasing. When the graph is falling, we say the function is decreasing. And when we've got a horizontal line, it's constant. It's neither rising nor falling. It's neither increasing nor decreasing. We will label our graphs to kind of get the ideas of those definitions across. So as I look at A, left to right, I can see that my graph is rising, meaning I definitely have a positive slope. Positive slope, we are going to associate that with this word increasing. So we'd have an increasing function. And as you look at the 6 graphs, can you find another graph that would also have a positive slope? It's going to be F, isn't it? So both A and F. The graph is rising from left to right. And so I'm going to label this one the same way. Positive slope, increasing function. Just for those 2 lines, as you compare them, you can see that the first one is not as steep as the second one. So I would say that this first one has a smaller slope, and the second one has a larger slope. right, let's look at graph B. In graph B, we have a perfectly horizontal line, so that means the slope is 0. There is no increase or decrease. And so that's the one we associate with the constant function. I don't have any other graphs to compare that to because a constant function always has a slope of 0, so there's really nothing more to say about that one. Take a look at C. That graph is going to be falling from left to right, so I'm going to say that one's got a negative slope. And we call that one the decreasing function. So a negative slope where the graph is falling, we associate that with the word decreasing. As we look at the remaining graphs, the other graph that also has a negative slope would be D. So if I look and kind of compare what's happening here in C and D, D also has a negative slope. So it's a decreasing function. And as I compare them, D is definitely a steeper slope than C. Now you want to be a little bit careful about the language that you use here. Technically, the slope of D is still smaller than the slope of C because a negative number with a larger absolute value is going to be smaller than a negative number with a smaller absolute value. But when I think about steepness, I really just want to think about the absolute value of the slope. So I'm going to say the absolute value of the slope is comparatively small here. This is not nearly as steep of a line. And the absolute value of the slope is comparatively large here. So here the slope has a smaller absolute value. And down here the slope has a larger absolute value. Now I'm keeping these all in general terms. If I was very careful, I might be able to actually calculate the slopes of these lines, since I did give you tick marks and values for x and y. But I can say that much without actually doing any calculations. Let's look at one more. In E, we have our vertical line. This is the infinitely steep line, and so we do have to say that the slope is undefined. There's no special word like increasing, decreasing, or constant here. Because we never travel from left to right, we really can't say that we're going up or going down or remaining the same. We're remaining at the same x value all the time. So an undefined slope is about all we can say about that graph. We'll continue this section in the next video. We've got some language here, some vocabulary, and we'll be continuing this section by looking at parallel and perpendicular lines.